Today we'll be solving question under Kirchhoff's law. This is the question. The question says that we should write down a set of simultaneous equations for the network shown below and find the values of I1 and I2. So this is the circuit. For us to solve this question, we will write down solution. We need to resolve this circuit into simultaneous equation by resolving into simultaneous equation. So from the circuit, we have loop 1 and loop 2. So we are going to start from loop 1. So from loop 1, we have 6 as our voltage source. It is positive because it started from positive terminal, equals to 1 multiplied by I1 will give us I1 plus this 6 into brackets I1 minus I2 plus 5I1. So 6 equals to I1. If you use this is to open these brackets, plus 6I1 minus 6I2 plus 5I plus 5I1. So by collecting the like time, we have 6 equals to 1 plus 5 plus 6, making 12. 12I1 minus 6I2. So 6 can go in it. So therefore we have 2I1 minus I2 equals to 1. This is our equation 1. So also from loop 2, we can see our voltage source. We don't have any voltage source, so therefore our voltage source is 0, equals to 6 into bracket I2 minus I1 plus 2I2 plus 3I2 plus 4I2. So therefore we use this 6 to open the bracket. We have 0 equals to 6I2 minus 6I1 plus 2I2 plus 2I2 plus 3I2 plus 4I2. By collecting the like time, if you add it together, 6I2 plus 2I2 plus 3I2 plus 4I2 will give us 15I2 minus 6I1. So therefore we can write it as minus 6I1 plus 15I2 equals to 0. So 3 can go there. Minus 6 divided by 3 will give us minus 2I1 plus 5I2 equals to 0. This is our equation 2. So let's rewrite equation 1 and equation 2. Our equation 1 says that 2I1 minus I2 equals to 1. Equation 1. And then our equation 2 minus 2I1 plus 5I2 equals to 0. This is our equation 2. So we have resolved it into simultaneous equation. The next thing we are going to do is that we find the value of I1 and I2. For us to do this, there are 5 basic methods in solving simultaneous equation. We can use elimination method, we can use substitution method, we can use graphical method, we can use Gauss-Jordan method and Cramer's rule. Here we are going to use Cramer's rule. By using Cramer's rule, we are going to write down the coefficient. We have 2 minus 2 minus 1, 5. So, and I1, I2 equals to 1, 0. So, I1 equals to change in delta 1 over change in delta naught. So our change in delta 1 is that we replace this row with this. So it will now be 1, 0 minus 1, 5 divided by our change in delta naught is this one, 2 minus 2 minus 1 5. So we find the determinant of this. This one will be 5 times 1 will be 5 minus 0 times this minus 0. This one will be 10 minus 2. So we have 5 over 8. So therefore, we have 5 over 8 equals to 5 over 8, which equals to 5 divided by 8, 0. 50 divided by 8, 6. Remainder 2. 2 divided by 20 divided by 8, 2. Remainder 4. 40 divided by 8, 5. Therefore, I1 equals to 0.625 ampere. So, to obtain I2, which is our Roman figure 2, to obtain I2, so from here, I2 equals to change in delta 2 over change in delta 0. So our change in delta 2 is that we are going to replace this row with this. So we now have 2 minus 2 1 0 divided by 2 minus 2 minus 1 5. So we have this one to be 2 times 0, 0 plus 2 divided by, we already know that this one is 8. So therefore we have 2 over 8. So therefore I2 equals to 2 over 8, which equals to 2 divided by 8, 0. 20 divided by 8, 2. Remainder 4. 40 divided by 8, 5 ampere. So therefore I1 equals to 0.625 ampere and I2 equals to 0.25 ampere. So these are the values of I1 and I2. Thank you for watching.